Hello and welcome to the video lesson, topic 8.2. We're actually going to make this two parts. So today we're going to talk about 45, 45, 90 triangles. And the next video lesson will be 8.2 part 2, which is about 30, 60, 90 degree right triangles. If you hear my dogs, just ignore them. I'm doing this live at home. Topic 8.2 is called special right triangles. And the learning objective is I am learning to use the properties of 45, 45, 90 degree triangles and 30, 60, 90 degree triangles. A quick overview of this is basically there's 180 degrees in every triangle. So 45 plus 45 plus 90 gives me 180, and 30 plus 60 plus 90 gives me 180. And whenever you have these set of circumstances, you have some special properties. Now these properties are on the back of this assignment, or if you're looking at the PDF online on Google Classroom, they are the second page of the topic. The special properties, today we're talking about the 45, 45, 90 degree triangle, and this is called the reference triangle. And you'll see that it has a variable s, and what this does is give us some special relationships for either side that's not the hypotenuse, and then the hypotenuse is going to be whatever this side length is, or your other side length, either of those legs. You would multiply that length times the square root of 2, and that would give you the hypotenuse's length. So what I like to do is, for instance, on example 1, have the reference triangle so I can refer to it. So I'm just going to draw it here. And you'll notice inside this triangle it says 45, 45, 90. Well, if that's the case, I can use this reference triangle's information. Now this first one's going to look pretty easy. I label the sides with S, which is just a variable, doesn't mean anything, it's a placeholder. I label each corresponding side with the values from the reference triangle, so S, S, and S root 3. Now the side that's given, for instance this side is 9, corresponds with that S. It's on the same side as the 9, so that means S is 9. So now that I know S's value, anywhere I see an S, I can replace it or substitute it with 9. So H, which is S root 3, I can replace the S with 9. That gives me H is 9 root 3. Done with part A. Part B. Again, you have a 45, 45, 90 degree triangle. So I can use this reference triangle with the S's and S root 3. And label the legs as S, and the hypotenuse, remember it is formed, it's the longest side, and it is formed across from the arrow, the right angle pointing at it. This side would be S root 3. Now the side that's given, which I typically circle with the value of the variable, in this case S root 2, should be substituted in for S here. Now this is going to look weird, but X, this side, is whatever you have for S times the square root of 2. So in this case, S is 2 root 2, and then you bring down this other root 2. So in other words, if S is 2 root 2, you'd replace the S. So there's the 2 root 2. And then you bring down the other root 2. And if you simplify this, 2 times root 2 times root 2, well, root 2 times root 2 is just root 4. And then the square root of 4 is 2. So 2 times 2 is 4. Or you could just stick that in the calculator. Our second example today, what is the value of X? This one's going to look a bit different because we have the hypotenuse given. And you'll notice on part A and part B, example 1, it was a leg given. So I'm going to draw my reference triangle here. Notice this is a 45, 45, 90 triangle. And we have S, S, S root 2. Now, if we label the sides with those values, you'll notice the side that's given, which I typically circle, like I said before, is going to be s root 2. Now, I'm going to set this up as an equation, just like I did up here. S is equal to 9, and s is equal to 2 root 2. Here I'm going to say s root 2 is equal to 6. Now, we want s so we can substitute it in for the sides. We're missing this leg, x. So you're like, how do I get rid of this square root of 2 that's being multiplied by the s? Well, you need to do the opposite of multiplying by square root of 2, which is dividing. So on both sides, we're going to divide by square root 2. So s is therefore equal to 6 divided by square root 2. Now, we don't want a decimal here. We want kind of simplest radical form like we've been talking about. I wouldn't just put x equals 6 root 2 because you may have learned this in data and measurements. You're not supposed to have a square root in the denominator or bottom of a fraction. So to get rid of it, called rationalizing the denominator, that's what we'll be doing, is you multiply by whatever's in the denominator, and these square roots will essentially cancel out. And what's going to happen is we'll get 6 being multiplied by root 2 on top, and in the denominator, square root of 2 times the square root of 2 is just 2. And then you can simplify it one step further. 2 goes into 6 3 times. So if we simplify, s is equal to 3 square root 2. And unfortunately, these are the harder type of problems where you're looking for a leg and you have the hypotenuse given, but that's just the nature of the beast. So now that you know s is 3 root 2, you can replace this s with 3 root 2, and you're finished with the problem. Takes a little longer, but it's completely doable. If you guys got questions, just comment them, or you can shoot me a remind. You can shoot me an email at jeremiah.stringer@pulaski.kyschools.us, or you can leave a comment on Google Classroom as a reply to the assignment, and I can respond to you.